Okay, now we're going to be organizing data. So previously we had collected the data, as you see there. We learned how to tally data, how to table data, how to group data. So we tallied it, we grouped it, and we put it in a big table, a frequency table, for example. Now we're going to learn how to organize data. And we're going to specifically do this with a stem and leaf diagram. And by the end of this video, we're going to have filled in something in here. And we're going to teach how to do a stem and leaf diagram. So the first thing you've got to know is that it's a great way to organize data. Now I'm really going to push, this is what you actually are doing. We are organizing the data. We've already collected it. So in a long jump competition, these were your friend's results in meters, right? So the data is being collected. We could have collected this while tallying, but we've done it now and it's here. So there were some people who got 2.2 meters, 3.2 meters, 1.9 meters. There's a 5.0 meters. So now we want to organize this data. So we're going to create a stem and leaf diagram. I'm going to speak more about how or why it is called a stem and leaf diagram soon. But for a moment, let's just assume that this is the stem and this is the leaf. So we have a table. We're first going to put 1 and 9, right? So this means 1. This is the first number here. And then 9. So this would equal your 1.9. Then you're going to have 2.2, 2.2, 2.4, 2.5, and 2.7. So we've done your 1.9. There's a 2.2. There's a 2.2 again. Then a 2.4 and a 2.5. Let's do the next one. Oh, and a 2.7. Let's do the next one. It's 3. So that's the first thing. We have a decimal place here that that's just how we are organizing our data, that we're just ignoring for now. So what is our lowest 3? 3.2, 3.2, and 3.6 and 3.8. So our lowest one is 3.2. Great. Let's cross that out. Our next lowest one is 3.6. Great. Let's cross that out. And our next lowest one is 3.8. Great. And let's cross that out. Now let's go to number 4. We have 4. The lowest 4 must be 4.0. So let's cross that out. There's a 4.1. And there's a 4.2. Great. Let's cross these out. And then we have left just a 5. And it's a 5.0 and a 5.1. Note that for the 5.0, it's okay to write the 0 here. So if you were to get a graph like this and told that these were the meters and these are the centimeters, and you were to write it out, you would be able to go, that is 3.2 meters. That is 3.6 meters. Make sure you can go from this table to this if I had asked this the other way around. This is why it's called a stem-leaf diagram. As you can see, there's the stem, and this is the leaf. So it doesn't always have to be decimals. Let's go to another example. These were the marks from your mathematics class out of 50% or 50 marks. So this is what each student got out of 50. Some students got 15, some got 40, there was a 7, there was a 49, there was a 50. Some people did really well. So how do we put this in a stem leaf? So last time the stem had a decimal between the stem and the leaf. Now we're just going to use the stem as the decades for each of these numbers, the tens of these numbers. What is our first 10 going to be? It's going to be 0. And it's going to be 0 and 7. And that's okay to write, because 7 does not have a 10 before it or added to it. What's our next one? So we can cross out 7. Next is going to be 10. Now what 10s are there? There's a 15. Is there any lower one? Yes, there's a 12. So it'll be 2 and 15. So this we can write as 12 and 15. Then let's look at the 2s. There's a 25. There's a 22 and another 25. So let's cross out the 22. We got 22. Let's cross out the 25, 25. And let's cross out the other 25. And I've just spotted that I've made a mistake here. I didn't see the 9, but that's quite alright because we can just add the 9 in over there. Now we look at the 3s. Now for 3, there's a 32, there's a 34, there's a 37, and another 32. So we're going to have 32, 32, 34, and 37. So this is a much easier way to represent the data or organize the data. Now let's do our 4. We got 4, 40, which is 0. We can cross that out. We got a 44, another 44, a 49, a 43. Okay, so we're going to have 3, 2 44s, and then a 49. So let's cross those out. 44, 43, 49, and then we have a 50 right at the end, 5 and 0. And there obviously could not be anything higher than 50. So we can cross that 50 out. So why do we make stem leaf diagrams? We organize the data to make it easier to summarize the data. Now summarizing is what we're going to do in the next section. Currently we're organizing the data. This is going to make it easier in the future, as it's very easy to find the range and medium. Have a look here. The range, remember we said, is the biggest minus the smallest. So very easily we can see that the biggest number here is 50 and the smallest is 7. So we can say the range is 50 minus 7. That's much easier to figure out, and we can tell that that equals 43. That's much easier to figure out than trying to look in this data set. We can also find the medium quite easily. How would we find the medium? Now the medium, I'm going to have a whole video on this, but it's the middle term. So we're going to cross off one at each side to find the middle one. Cross, cross. One at the top, one at the bottom. 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 One at the top. Okay. And then we crossed them all off and we got to 2. And then we can tell that 3 and 2, we know that the medium of this data set is 32. And you're going to see why it makes it so much easier in the future. You don't need to worry about calculating the medium and the range now. These we're going to do in the future. But just know that this is why we want to make stem leaf diagrams. Well done. We can now add a stem leaf diagram into this box here. And remember, that is organizing data. Now we're going to get into summarizing data and what that all means.